Welcome to another Anatomy and Physiology Smart Art video, where we guide you through an important piece of art. After watching this video, you should be able to describe the role of the pancreas in the homeostatic regulation of blood glucose. Let's begin by looking at this image showing the location of the pancreas, inferior to the stomach and adjacent to the first portion of the small intestine. The pancreas is both an exocrine gland and an endocrine gland, but in this video we will focus on its endocrine function. The endocrine cells of the pancreas are concentrated in pancreatic islets, also known as the islets of Langerhans, that produce hormones regulating blood glucose. Looking at this histological image, we can see the endocrine pancreatic islets as well as the exocrine pancreatic acini. Looking closer, we can see that each pancreatic islet is made of many different cells. The cells of glucose metabolism are the alpha cells that produce the hormone glucagon and the beta cells that produce the hormone insulin. These two hormones both function via negative feedback. Now, let's look at an image demonstrating this process. Recall that negative feedback includes a stimulus that disturbs homeostasis, receptors that detect and respond to the stimulus, and effectors that restore homeostasis. Normally, blood glucose oscillates between 70 and 110 milligrams per deciliter of blood. Now, suppose something happens to disturb blood glucose homeostasis. For example, you eat a meal. As a result, your blood glucose rises. This change in glucose level is a stimulus which is detected by receptors found in the beta cells of the pancreatic islets, causing them to secrete insulin into your bloodstream. All of your body's cells are now exposed to insulin, and those cells with insulin receptors respond to the higher insulin level in several ways. The rate of glucose transport and absorption into target cells is increased. These cells also increase the rate at which they use glucose to generate ATP. They also convert more glucose into stored glycogen for future use, especially in skeletal muscle and liver. Increase the rate of amino acid absorption and protein synthesis to prevent the conversion of amino acids to glucose, and increase triglyceride synthesis in adipose tissue to store energy for future use. All of these responses result in a return to normal blood glucose level, which restores homeostasis. Now, let's move to the bottom half of the art and an opposite stimulus. In this case, homeostasis is disturbed by decreasing blood glucose. Maybe it's been hours since your last meal, or perhaps you're exercising. As blood glucose drops, the alpha cells of your pancreatic islets have the receptors that detect this stimulus. The alpha cells secrete glucagon into your blood. The higher blood level of glucagon acts on effectors such as your liver, skeletal muscles, and adipose tissue. The effects include breaking down glycogen into glucose in the liver and skeletal muscles, breaking down fat into fatty acids in adipose tissue, and increasing the synthesis and release of glucose from the liver into the bloodstream. The result? Blood glucose level increases to normal and homeostasis is restored. In summary, the alpha cells and the beta cells of the pancreatic islets regulate blood glucose homeostasis. As blood glucose level increases, the beta cells secrete insulin, which causes glucose to move out of the blood and into your tissues. And as the blood glucose level decreases, the alpha cells secrete glucagon, which causes glucose to move out of tissues into your blood. So what? Why is it important to understand the homeostatic regulation of blood glucose? Well, this knowledge is crucial to understanding diabetes mellitus, a group of diseases characterized by prolonged elevated blood glucose level. In type 1 diabetes, the beta cells do not produce enough insulin, and people with this condition must inject or pump insulin into their bodies. In the U.S., most cases are type 2 diabetes, in which the cells do produce insulin, but tissues don't respond to it. Type 2 diabetes is associated with obesity and lack of exercise. If either type of diabetes is not managed properly, the chronically elevated blood glucose level can damage tissues throughout the body, causing problems such as blindness, cardiovascular disease, and kidney failure. Diabetes can also result in reduced blood flow to the periphery, which can lead to tissue death in the toes and feet, requiring them to be amputated.